Hey, good afternoon, everyone. Welcome to the Econometrics 1 course. So I think we're still waiting for other students to join, but I think we can start. It's good to have everyone here in the course today. It's been a while since we had lectures, so it's a welcome change to the daily pace of life. I'm hoping that everyone is safe and healthy amid the pandemic. I think it's a difficult time for everybody, but I hope that everyone is gonna have a easy task of adjusting to the daily life. So before we start, I think I'd like everyone to turn on the video unless it is necessary for you to turn off the video. I just want to make sure that you guys are engaged and you guys are paying attention to the lecture materials. And so I'd like you guys to turn on the video. Go ahead. Okay, good. So I'm hoping that you guys can stay engaged during the course. So I'm gonna throw out some random questions in the middle of the lecture, and I'm probably gonna randomly pick students to answer the questions or get some kind of feedbacks for the question. So be prepared, and I think we can start now. Okay. So welcome to the course. My name is Gumilang Aryo Sadewo. You can call me Gilang. I will be your instructor for the rest of the semester for Econometrics 1 course. I will be assisted by Helga, Mutiara Helga. She's your senior at the economics program. She did a very good job on the Econometrics 1 course, and she finished top at the microeconometrics course last semester. And so I'm so happy that Helga could be on board, and she's going to be your TA for the rest of the semester. So you guys are in safe hands. Okay, I guess I'll start with announcements on the class logistics. I think this is going to be important so that everyone is on board and understand kind of like the nitty-gritties of the class. Okay, so I'll start with the syllabus. So reading the class syllabus is actually a must. And so if you guys have any questions or if you guys have any concerns regarding the syllabus, you can always raise it to me via email, or you can always ask it during the meeting. I'm gonna provide you with an opportunity to ask questions about the class syllabus after this. Okay, so the next step is just logistics before each meeting. So I want you guys to read the relevant chapter for the upcoming meeting. And so I understand that not all of you had the opportunity to read the first chapter for today's meeting. That's fine, but for the upcoming meetings, I'm hoping that you set aside a time during your weekend or probably Friday before the lecture just to read the chapter 2, and then kind of like deep dive into the chapter and take notes on what's important in the second chapter. And so I'm hoping that the lecture will be more or less confirmatory of the readings that or the concepts that you haven't understand. Also, if if you haven't done so, please download the data for Stata. It's already available in ELOC, so you just have to download it, and it's basically going to be the data set for the whole semester for your assignments as well as for your tutorial. In some courses, in some classes, I'm going to have you open a do file in Stata with the directory set to the one which you saved the data. And so this way it's going to be easy for you to call the data. And if you have any, things to save, that you can save it in the same directory. So it's not mandatory to save it in one particular directory, but it's a good way of managing the data. Okay. I will post lecture notes, do files and videos in ELOC. So I sent you instruction on how to register to ELOC, so you guys can do it if you haven't done so. If you have done it, that's great. You'll probably be able to see the materials for today's lecture. We're going to have quizzes, we're going to have problem sets as well. And so that's, basically kind of like the course management for the whole semester. So I think that should be your main reference for ELOC. If you have any difficulties in accessing ELOC, please let me know. Okay. Again, I just want to point out that you should read the relevant chapter in the textbook prior to each class, and then pointers in the lecture notes should confirm what you've read. And I basically in the course, if you have a face-to-face meeting, I discourage everyone to take handwritten notes of all the points in the slide, because you already have the slide. You don't have to take notes of all the points again. It's going to be too slow for you, and you're gonna, I think, miss the important concept. And so if you guys can go over the lecture slide, really understand the points, and so what you take down in the notes is really just a confirmation of what you've learned. If you take a note for the sake of note taking, I think you're going to be behind. Okay, so I think this is important note that I need to say as well. I always encourage students to work in a group of 2 or 3 to discuss important concepts in class and in problem sets. The idea is not to free write, but the idea is to collaborate. And so ideally, you should be reviewing the materials and doing the problem sets by your own individually. And then if you have difficulties, then you can get together and then discuss the concepts or the problem sets. One indication that you understand the materials if you can explain it to your classmates about the concept. And so I think working in a group is also a good opportunity for you to recall the concept and then share the concept for your other colleague. It's always a good practice, and I encourage everyone to try the practice. Now, if you don't understand a concept during the course, you can always ask me. There is a raise your hand feature in Zoom, but if you want to interrupt me, just turn on the audio and then ask the question. If we go ahead and then you skip a couple of slides that you haven't understand, it's going to be difficult for you to follow the next concept. And so do ask me, and there is no I will not be offended if you turn on your audio to ask questions. Just be clear. Okay. Again, if you're left behind, ask me to repeat the concept, and do not ask your friends, during the course. She may not understand the concept too, and it's always good for you guys to ask to me. If you can keep your chat down during the course, that would be nice. And this is not going to be an issue in online lectures, since you all, take opportunities to mute, but please pay attention just during the course so that you can understand the core of the lecture. Okay, so this is mandatory for me to say, but it's the university copyright rules for not taking pictures or video unless you get permission. We can always have the video recording of this lecture uploaded into Google Drive and into YouTube at the end of the day, and so you can have it. You can have an access to the lecture the following day, so you don't have to worry about that. And then I'm asking each and every one of you not to post any of the lecture materials online or in any cloud storage without my permission. I think this is going to be a straight rule, and so I really hope that everyone can follow. I'm also going to take a hard stance on plagiarism on assignments. And so you should always do your assignments by yourself. Again, I'm not going to limit you if you want to collaborate and then discuss it with your friends, but you have to submit your own homework. You have to submit your own project, unless it's a group project. Okay, I don't want you, take your friends' problem sets and then copy it as your own. I think that's going to be a violation of the plagiarism rule. Just a note, I reported 7 students last semester to the Vice Dean of Academics because they did plagiarism on their final assignments. And so all of those 7 students got an E, and they have to retake the course next year. So it's not going to be beneficial for everyone, but please follow the rules. Okay. All right. Again, I'm not going to entertain any requests for quizzes, pop quizzes, or exam makeups. I will not entertain requests for assignment makeups as well. And I'm not going to entertain any extra assignment if you score low on your exam. So you take it as it is. It's for the fairness of everyone in the course, especially students who work hard. And so I'm expecting that everyone are going to act like adults, act as adults, and then take responsibility as adults. And so I will implement fairness in grading. And so my grades are usually final, but you have the rights to review your exam in front of me. Okay. All right. So I think that's going to be like the general announcement for the class logistics and kind of like my expectation for everyone in the course. I'm going to open up the opportunity for you guys to ask about syllabus or anything related to class logistics. Go ahead. Let me know if you have trouble unmuting yourself, but I think you should be able to unmute yourself and then ask questions. It's always good to clarify any of your concerns or any of your questions before we start the eventual lecture. Go ahead.
Sir, can I ask something?
Sure, go ahead.
In this course, the tools that we are going to use most often is going to be the R or Stata, sir.
Okay, thank you, and a good question.
Thank you,
so
sir.
basically, I'm going to use data for I think all of my lectures, but again, I think you have a plethora of options that you can take. You can use Stata. You can always use R. R is a good software in the sense that it's an open source, so you don't have to pay for license and stuff like that. Stata and R are actually the two softwares that I'm going to recommend for this course. But if you want to use like eFuse or if you want to use SPSS, I'm not gonna say no to those options, and so feel free to use it. But I'm going to discourage you guys to use Excel, just because I think the capabilities of Excel is going to be way below the capabilities of Stata, and then for R, especially for a large data set. Okay, and so you have the opportunity, you have the freedom to choose, which software that you want to invest yourself in. So since this is a econometrics 1, in the sense that it's a fundamental econometrics course, you can use Stata, and then if you're confident enough, then next semester during the microeconometrics or the macroeconometrics course, you can use R. And so it's good after you graduate from the Faculty of Economics and Business, you're already familiar with Stata, you're already familiar with R. I think that's gonna add to your arsenal when you go into the job market and then apply for job. Okay, good. Other questions, clarifications? Go ahead.
Sir, I have another question.
Sure.
Well, is there any minimum requirement of knowledge and skill in using those software that you mentioned in order for us to do the problem sets, or do we learn as we do the problem sets?
Yes, I think it's going to be very, very quick for you guys to learn Stata, for you guys to learn R. I think there are many resources that you guys have an access on, to understand more about the basics of, say, data management or simple user interface for R and for Stata. And so I think you're not going to have any difficult time to use Stata and R for the first time to do the assignments. But yes, as you go along, you will learn more about Stata in particular, and then you can also set independent time if you want to learn other software such as R or SPSS and stuff like that. I understand that we have business students and also an accounting student as well in this course, and I'm not going to force them to use Stata or R just because they might not use it in the future. And so if they want to use SPSS, I think that's fine by me. But for the sake of course delivery, I'm going to use Stata.
Thank you, sir.
Sure. Go ahead. Any other questions, clarification? Just get it out. Get it out of your chest, because I don't want any stumbling blocks after the Q&As. Go ahead. Okay. All right. I think everyone is quite settled on the syllabus as well as on the, like the general class logistics. Again, if you prefer to ask me, via email, do so. But if you have any other questions that you cannot say it out loud, you can always use the chat. Okay. All right. So for the sake of time, I'm going to start the lecture. In particular, I'm going to go through the materials in the slide deck. I'm hopeful that some of you has, had an opportunity to review the reading, especially Jeffrey Wooldridge chapter 1. I think it's a very, very enlightening chapter, and it's a very good chapter for you guys to really sit down and then learn econometrics for the rest of the semester. So I'm going to invite you guys to read chapter 1, and it's going to open up your aspiration about this course. Okay, so let's start. So with the first question, what is econometrics? So econometrics is basically a collection of mathematical and statistical tools combined with economic theory. So, economic theories is basically assumptions about the world. And so I think theories have predictions, and one of the use of econometrics is actually try to prove the prediction of these theories. So during the semester, you guys are gonna revisit a lot of the tools that you've learned in the first and second semester on mathematics and then statistics, like derivations, partial derivatives, and then expectations, conditional expectations, normality assumption and stuff like that, hypothesis testing. And so all of the things that you've learned in the mathematical and then the statistical course are gonna come back to life, basically, and it's ready for you guys to use it. And so I'm hoping that you guys still have an access to the resources that you had for mathematics and for statistics, and then you can always revisit those tools during the econometrics course. Okay. All right. So why do we want to learn econometrics? At the end of the day, what is econometrics used for? So basically, I think one of the things that econometrics is very useful is actually to measure population quantities of interest. So again, if you go back to your statistic lecture, you have population, and in the population you have the parameter. Basically, no one knows the value of the parameter. It's just something that the God knows. And so the idea is that we're going to collect a random sample, and then using the random sample, we're going to have an econometric model and econometric specification, and then we're going to use that to measure a specific parameter in the population. Okay, and so there's a lot of population parameters of interest. It could be college wage gaps. Okay, so suppose you have individuals who graduated from college, like yourself, in 2 or 3 years, and then you have individuals who just graduated from high school. Now, how big is the wage difference between those who graduated from college and those who graduated from high school? And so this is referred to as the college wage gaps, which is actually a return, one of the one of the population quantities of interest if you want to estimate the return to going to college. And so this is actually something that we're interested in. Okay. Another one is that we're interested in estimating economic parameters. And so if you recall from your microeconometrics course or your intro to economics course, you've heard about price elasticity of demand. You've heard about wage elasticity of labor supply and stuff like that. So those are economic parameters, and these are the parameters that we're interested in. Again, we don't know what's the value of the parameter in the population. And so we're going to use econometrics model. We're going to use econometric specification and the data to try to actually estimate the price elasticity of demand. I think this is going to be very important for policy purposes. And so, for example, here, I'm listing price elasticity of demand for sugar sweetened beverage. And so if you follow the discussion, particularly by the Directorate General of Excise Tax in the Ministry of Finance, they've been, having kind of like a policy debate on whether or not they want to introduce excise tax on the sugar sweetened beverage. And so if they introduce excise tax, that's going to increase the price of the sugar sweetened beverage, and so that has potential to actually lower the demand for the sugar sweetened beverages. And so understanding the parameter is actually going to be very important to identify how big is going to be the revenue generated from such policy, and then how big is going to be the loss in demand owing to the excise tax. So that's one example on why we want to use econometrics. Another one is actually to try to determine the effects of certain treatments on certain outcomes. And so in this course, I'm going to introduce you to the idea of, very preliminary idea of impact evaluation using econometrics. And so basically what we're trying to do is we want to know whether or not a specific program, a specific intervention, or a specific treatment has an effect on a certain outcome. Okay, so for example, the government has a conditional cash transfer program called CCT, or in Indonesia, we call it the Program Keluarga Harapan. Or the Indonesian government implemented the Bantuan Siswa Miskin. So this is like the For Poor Students cash transfer program. And we want to know whether these programs actually have an effect on the outcome. So for example, we want to know whether or not the PKH has an impact on the child stunting rate. We want to know whether the Bantuan Siswa Miskin program has any effect on the student achievement in the school. And so this is something that we're interested to do using econometrics model as well as the data set. Okay, I think this is going to be interesting, and perhaps you may not be able to grasp the idea of the effect of certain treatments and outcomes, but I think you will learn more as we go along. Okay, all right. I think the last point on the use of econometrics is actually to test or mediate between competing economic theories. If you guys are interested in the economics of education literature, or if you're interested in the labor economics literature, I think one of the theories that you guys will learn is the signaling theory and the human capital theory. And so these are the two theories that try to explain the college wage premium. So how big will you get if you have a college degree in comparison if you just have a high school degree. So a human capital theory says that as you attain more schooling, you get more productive, and that higher productivity is going to translate into higher wages and stuff like that. On the other hand, the signaling theory is going to allow the employers or the firms to actually identify your unobserved skills or your unobservable characteristics. Okay, oh, this guy has a diploma, like a bachelor degree, and so not only that the bachelor degree conveys things about their academic achievement, probably their leadership quality, their communication capabilities, but also some unobservable characteristics such as their motivation, their drive, their grades, and stuff like that. And so econometrics is going to be very useful in trying to test or mediate between competing economic theories. Okay, I'm going to pause here for a moment, and I'm going to take in questions. Go ahead. Okay, all right. I'll continue then. Again, if you have any questions in the middle of the lecture, just unmute and then ask. I don't want you guys to, be left behind on a particular concept, because we're going to move on and then use that concept for learning another concept. Okay. All right. So how, does econometrics differ from statistics? Well, there's actually, substantial overlap and interaction between econometrics and statistics. And so I think the differences arise due to the nature of economic phenomena, which are often preclude a straightforward application of standard statistical methods. When we're talking about supply and demand, it's not going to be straightforward if we only know statistical tools. We also need to know the economic phenomena and then the theories behind the supply and demand. And so the supply and demand is going to guide us to learn about the theories and then what the theory predicts. And then statistics is going to help us to uncover, population of interest, such as the parameters and stuff like that. Okay. And when standard methods cannot be used, economic theories will suggest alternative approach that allow us to answer the question of interest. Okay. And econometrics deals with formalizing these methods and proving that they work. Now, this is actually a very important, I think, point. So economists in general are interested in causal relationship instead of just correlation. Okay. So we're going to come back to this notion of causality versus correlation. I think this is a very important note that everyone must understand, and I think this is going to be very essential in the econometrics course as we move along. So take note of the idea of causality and correlation, and we'll revisit this in a couple of slides. Okay. All right. Why do we need econometrics? I guess I've touched upon this idea a couple of slides ago, but I think I just want to try to reiterate and then highlight. So theories often give the sign of an effect, but not its magnitude. Okay. And so, the theory says that if you attain more schooling, then on average, you will have higher wages. But by how much? We don't know until we do the econometrics modeling and then get some estimate. How big is the college wage gaps? We don't know how big the college wage gap is. We can predict that the college wage gap is positive, but we never know the magnitude of the college wage gaps until we do the data set and then run some estimates. It's also going to be essential for policy analysis. So I've mentioned before, what's the effect of a higher SSB excise tax on SSB demand? I've also done studies on cigarette excise taxes, and so we're interested in looking at how big is the effect of higher cigarette excise tax on cigarette demand in general. I think that's something that's also very interesting. Another thing is that predictions from the theory are often ambiguous and rely on unknown parameters. And so, for example, will a higher wage induces individuals to work more hours or less? We don't know for sure. We have to look at the data. The theoretical prediction is not straightforward. It could be the fact that higher wages actually induces people to work more, but under certain conditions, higher wages actually induce individuals to work less. It really depends on the magnitude of the income versus the substitution effect. So this is kind of like the idea that we need to dig deeper to really understand, and econometrics actually provide you with the tools to try to produce some estimates about unknown parameters in the population. Okay. All right. Any questions before I move on to the second set of discussions on working with observational data? Go ahead. All right. So I'm gonna prepare a video. This short video actually provide you with a very useful discussion on the distinction between correlation and causation. And so I'm gonna do the video, and so that you guys can review the video. And after the video, we're gonna do some discussions. Okay. Okay, so I think that's gonna provide you a very brief introduction on causality and correlation. I think it's a very interesting kind of like concepts, and a concept that you guys have to try to understand and try to learn during the semester. Okay. So before we go into the class discussion, anyone wants to share the difference between correlation and causality? I think they gave us a very interesting example of causality versus correlation. If you guys can reshare what he said, I think that's going to be great. Or if you have another example, I think that would be nice. Anyone?
Hello, sir.
Yes, go ahead.
May I share my take on this one?
Sure. Go ahead.
Okay, so what I got from the previous video is that in general, to easily understand the difference between causality and correlation is that with regards to causality, it is in which event A could cause the occurrence of event B, while correlation is in which event A and B occurs at the same time, but people often connects event A and B as if B might cause A or A might cause B. For example, probably I'm also wondering what are your opinion on this one. This is an example that you have previously mentioned in the slide as well, such that people who work harder might get a higher wage. But could it be possible that two events could actually in which event A could cause B and B could also cause the occurrence of A, in which if someone works harder, they might get higher wage. But what if higher wage could instead motivate them to work harder? How do economists take this into account?
Yes, exactly. So thank you, Alexander. And so basically, that's kind of like the gist of causality versus correlation. It's very easy just to kind of like boil it down to just two variables. So suppose that you have A and B, or in this case, you have Y and X. And so you really want to know whether X causes Y, or is actually X, is correlated with Y, and Y is correlated with X at the same time. So in that particular case, we won't be able to claim that X causes Y, because X and Y are actually correlated with each other. And so just to respond to Alexander's questions, I think this is the issue that we're going to discuss a lot more as we go on. And so if you have X that is correlated with Y, and then Y is correlated with X at the same time, we have what we call simultaneity. Okay. And so if we have the issue of simultaneity, then it's going to be very difficult for us to identify the causal effect of X on Y. So, we need more discussions, and we need more advanced econometric data and advanced econometric model to try to uncover the causal effect in the case of simultaneity. And so I think that's something that we're going to learn, as we go on in the semester. Okay. Any other questions or clarifications? Any opinions? Okay. So I think we can go on and then do the class discussion. Okay. So the first point that I'd like you guys to think about, I'm going to give you like a minute to try to think about these points, and then see whether this is a correlation or a causation. Okay. So smoking and cancer, or a likelihood of getting a cancer or contracting cancer. So is it correlation or is it causation? And explain your reasoning. Okay, I'll give you guys. Oh, someone wants to answer. Go ahead. Can you please state your name?
It's Arzak Zidan.
Okay, go ahead.
I think it's causation because, well, as we can read in the box, a cigarette box, smoking may cause cancer. So I think it's causation because the smoking itself may cause cancer or increase the likelihood of contracting cancer. That's my answer.
Okay, thank you so much for sharing. And then any other? Yes, go ahead.
My name is Bagus. I think it's causation because if we break it down to two premises, if you say smoking might cause cancer, it might, but the second premise is that not all type of cancer is contracted because of smoking. That's why there are no sign of simultaneity, as you said before. So it's easier to distinct the causation effect in this particular scenario, sir.
Okay, thank you so much, Bagas. I'll give one more opportunity for students to state their opinion. Again, there is no right and wrong. You can state your opinion. This is a risk-free forum, and so go ahead. Okay, so yes, go ahead.
Actually, this is not an opinion. I just want to maybe ask you and the rest of the class to maybe enlighten me. If smoking and cancer is causation, then how do we explain the occurrences of people who smoke and live a long life? Yeah, so that's my question.
Okay, I think I'll answer that. First thing, so as economists and as someone who learns statistics in general, I think we're interested not in anecdotals, not in anecdotal evidence, but we're very interested in the average. Okay, and so if we say that x causes y, then we're talking in on average. Okay, some econometrics tool allow us to actually understand the median. But the idea is that we cannot take one anecdotal evidence and say that, oh, the empirical results are not true because of that one anecdotal evidence. And so if you find someone who smokes and then lives a long life, he's probably not the average. Okay, but the average study shows that if you smoke, then there is a higher likelihood of contracting a cancer or getting a cancer. Okay, now I just want to make to point out that smoking may not be the only the only behavior that leads to cancer or leads to a higher likelihood of contracting cancer. It could be the diets, it could be the foods that they eat, it could be their exercise, it could be exposure to pollution, it could be the amount of sleep that they get, and so on and so forth. And so studies have shown, yes, smoking causes cancer, but when you do your analysis, you have to make sure that you control for other factors that at the same time could also lead to cancer. And so by controlling other factors that may lead to cancer, then you can claim that smoking causes cancer, for example. Now, this is an idea that I introduced from the very beginning, and then we're going to discuss more as we go along. Okay. All right. I'm going to go into the second point: years of schooling and labor market wage. So, is there a correlation or is there a causation? And if you guys can have any idea on whether years of schooling increases your labor market wage or years of schooling actually decreases your labor market wage, go ahead. If you want to think through like 20 seconds, that's fine. If you have any opinions, Go ahead and unmute.
Excuse me, sir.
Yes, go ahead. Excuse me? Yes, go ahead.
I'm actually not asking about the specific year of schooling, but I'm asking about all of those three. So basically, can I say that all of those three, smoking, years of schooling, and bantuan siswa miskin, is basically, we can say that all of those correlation and causation. For example, like the smoking, we can say it is a correlation if we don't have any enough data, we just compare it like smoking and cancer. But we can say that it is a causation if we have a controlled environment. For example, in that environment, we have scientists that basically eliminated many of those factors. So we know that the smoking is basically the cause of the cancer. That's the causation. Like, and years of schooling and life record, if basically if we don't have any enough data or controlled environment that eliminated those factors, basically we can say that it is a correlation. But if we have a controlled environment, we can say it is a causation. Can it be like that, sir? Basically, all of those three is basically, we can say it is a correlation, but if we don't have enough data, but we can say it is also a causation. But if the environment is basically controlled, so we can eliminate any of those factors, so we can make it a causation like that.
Okay, very good, Jovan. So you're getting at where we're going, so that's very good. So yes, we can see it two ways. So for example, the years of schooling and labor market wage, it could be a correlation, it could be a causation, or it couldn't be a causation because we're leaving out other factors that we need to control, or ideally we need to control. And so yes, the idea is that we cannot say for sure whether this is a correlation, and we cannot say for sure whether this is a causation for many things. And those are the things that we're actually gonna deep dive into the rest of the semester. So for example, for the years of schooling and labor market wage. Okay, so suppose that you completed 16 years of schooling after you graduated and get your bachelor degree. And the theory says that on average, people who get or attain higher years of schooling will on average get higher labor market wage. Now, we cannot say that's a causation because there are other factors that affect the labor market wage and at the same time correlated with your years of schooling. So for example, your ability, another example is your motivation. So those things are very much correlated with your years of schooling. At the same time, it also affects your labor market wage. And so we cannot say for certain that the only thing that affects labor market wage is years of schooling, because there are other unobservable characteristics. And so if you really want to make a statement that years of schooling causes labor market wage, then you have to make sure that you control all the other characteristics, whether they are observed or unobserved. Okay, so that's going to be the idea moving forward. So yes, it's you can say that this is, for some cases, it's correlation, but it could also be causation. So I guess the next example, which is the bantuan siswa miskin and the student achievement, is, I guess, a perfect example. So can anyone give an opinion on whether this is a correlation or a causation? Although from my previous statement, you should already know the answer. Go ahead. So, or at least what's your prediction on the effect that, yes, go ahead.
I think if bantuan siswa miskin is based on, say, income, then of course it's correlation, I would say, because there are many other factors such as IQ, for example, or maybe household conditions that are not taken into account in affecting the educational outcomes. But in my opinion, if it was, say, like merit scholarship and not need-based scholarship, I would say that the causality might be reversed, in that merit scholarship is caused by the achievement and not that the scholarship is causing the achievement. I think that's my take.
Okay, very good. So there you go. So let's start with asking who are the students who get the Bantuan Siswa Miskin program. Okay, so on average, students who get the Bantuan Siswa Miskin program are the ones who's coming for poor or vulnerable families or households. Okay, on average, these students have a lower student achievement than those coming from middle class or upper class families or households. Okay, and so when you see the correlation between Bantuan Siswa Miskin program and student achievement, they could be negative correlation. But then you say, wow, there is a negative correlation between Bantuan Siswa Miskin program and student achievement. Should we be spending money to get the Bantuan Siswa Miskin program to these children? And so this is the issue when we base our policies or when we base on conclusion based on correlation but not causality. Okay, so in this case, if you collect data on people who get the Bantuan Siswa Miskin and then people or students who do not get the Bantuan Siswa Miskin program and then get their student achievement, do the regression, then you may get a negative correlation between Bantuan Siswa Miskin and student achievement. And basically it's correlation, it's not a causality. So you should not be basing your policy or evidence based on correlation, but you should be basing it on causation. So what would be the ideal kind of like exercise, or what would be the ideal kind of like quasi-experiment for us to do to identify the impact of Bantuan Siswa Miskin program and the student achievement? Again, this is something that you guys will learn in the coming weeks and this semester, is to try to tease out what's an exogenous variation such that students receive the Bantuan Siswa Miskin program, and we're going to take advantage of that exogenous variation to try to identify the causal effect of Bantuan Siswa Miskin and student achievement. Okay, so it may not sound obvious for everyone in the course right now, but I think it will be quite obvious in the coming weeks. Okay, so let's hold off on that discussion and then so that we can move on. But any other questions before I go on to the next slide? Clarification? Okay, good. All right, so I guess we're going to be discussing a very interesting and very important slide here. So basically, as researchers, you may encounter two types of data. One is experimental data, and second is non-experimental data. Okay, some people also say that this is observational data. So for example, let's go back to the first topic that you guys discussed in the previous slide on smoking and cancer. So it's going to be very difficult for us to do an experiment and then randomly assign people to smoke and randomly assign people not to smoke, because we know that smoking is bad, and so it's not going to be, it's not going to be accepted by the ethics committee or the institutional review board, for us to get people to smoke, just for us to know whether they're going to get cancer or not in 5 years or in 10 years. And so in that particular case, it's going to be very, very difficult for us to do an experiment. And so in that case, we might be doing, econometrics investigation using non-experimental data. It's also going to be difficult for us to use experimental data to identify the effect of years of schooling and labor market wage. We cannot just say, hey, you're a group of students who randomly assigned to go to college, and you're a randomly selected student who just stay and, stay as high school graduate and don't take college. And so that's going to be ethically difficult. And so experimental data for that kind of question is also not possible. And so in that cases, we're going to deal with non-experimental data or observational data. However, for example, the third option, bantuan siswa miskin, or say any kind of like cash transfer program, the government may kind of like decide on conduct an experiment. And so they will randomly choose families or households or students to get the cash transfer program, and then assign another group of households, students, or families to not get the cash transfer program. And then they're going to track in, say, 6 months or in a year, whether or not the student achievement differ among those who receive the cash transfer program and those who do not receive the cash transfer program. In that case, you could be dealing with experimental data. Now, again, ideally, we would like an experimental data, but there are pros and cons of having experimental data. So experimental data is going to be collected through controlled experiments. It could be on individuals, it could be on firms, it could be on schools, it could be on households, for example. We call it the field experiment, or randomized controlled trials, or randomized evaluation. Now, while it's quite difficult to obtain in social sciences, however, I think in the past maybe 40 years, randomized evaluation in social sciences have been gaining traction, okay? So if you guys follow the Nobel Prize winner, we have Abhijit Banerjee, we have Esther Duflo, and we have Michael Kramer. You know, these three scholars have been working on randomized evaluation or randomized controlled trials or field experiments in economics for the past maybe 2 or 3 decades. And they've given so much contribution to the literature, to the discipline, as well as to the policy-making realm. And so such that, you know, they've been received as one of the tools to identify the impact of social programs or interventions and stuff like that. So it's been getting traction, but again, for many researchers or for many people, doing experiments is not going to be straightforward. There are many challenges in trying to do experiments. The logistics are quite difficult. The costs are, you know, sometimes quite expensive. But if you get creative, you can actually do a lot of things using online, using Amazon MTurk, or perhaps in one day we can do experiments using Instagram, Facebook, and stuff like that. So, you know, keep your curiosity open. You know, perhaps one day you can uncover some interesting things. And so suppose that we don't have experimental data, we can always use the non-experimental, or what we call the observational data. So these are just the 2 examples that we may have. The National Socioeconomic Survey, SUSENAS, the National Labor Force Survey. We also have the Indonesian Family Life Survey, or called the IFLS. You know, if you guys are interested in health, we have the Riskesdas. If you guys are interested in, say, firms, you can always use the survey industry or survey UMK, micro and small enterprises and stuff like that. And so there are many non-experimental data, and of course there are also data you know, available online. We're going to introduce you to some of those data, but you know, it's going to provide you with kind of like a bigger picture that there are experimental data, there are non-experimental data, and we're probably going to be working more on non-experimental data. Okay. All right. Any questions on the idea of experimental versus non-experimental data? Okay. All right. So I'm gonna, you know, discuss more about experimental and observational data. So basically, in an experiment, you know, a researcher can really control how and to whom a treatment is given. Okay. So there are interesting experiments in social sciences and economics, you know, that I think are very interesting, and I actually invite you guys to read some of this interesting papers. So for example, the effect of information on return to education on graduation rate. So if you go to developing countries, you know, including Indonesia, for example, if you look at school enrollment rate, it's, you know, been increasing in the past 2 decades, and actually for elementary school, we've observed what's called the universal enrollment. Okay, now that doesn't mean that when kids go to school they actually learn. Okay, and so it may affect their learning and then eventually their graduation rate. So there are some factors that identify on why people don't really, take their schooling seriously, or if they have the opportunity to go to school, they don't take it, as rigorously as they should have. And the idea is that they have a belief that even if they graduate, it's going to be difficult for them to get jobs. Even if they get, a junior high school diploma, or if they get a high school degree diploma, they might not have the livelihood that they get. And so they choose not to graduate and, perhaps don't go to school. And so one of the things that, past researchers have done is try to give particularly parents the information on the return to education. So for example, if you finish junior high school as opposed to elementary school, then your wages in the labor market will be higher by, say, 8.5%. Just giving you an arbitrary example, but that's the way that it's being experimented. And so by parents knowing that that their kids will actually get a higher wage if they get a junior high school diploma, then they can push their kids to attend schools, to do better on their schooling and stuff like that. Okay. Another concern, facing kids in the developing countries is a high share or a high incidence of diarrhea. Okay. So there are many reasons on why kids in the developing countries contract diarrhea. It might not be relevant in Indonesia, I guess, in the past decade or maybe 2 decades, but I guess when I was a kid, diarrhea is still a thing. And if you go to Africa, if you visit Kenya, or if you visit Ethiopia, or if you visit, major African countries, you can find that the incident rate of diarrhea is actually still very high. And it has a very high cost, not only current cost, but also long-term cost in terms of they were not able to go to school because they had diarrhea and stuff like that. And so they tested the effects of deworming. So basically, these are kind of like pills given to the students, and they're going to test whether or not the deworming has an effect on school dropout rate. So it's very interesting. Okay, and so the opposite holds for observational data. So in experimental data or in experimental research, you can control who get the treatment and who don't get the treatment. But in observational data, you don't really have the privilege to control who gets the treatment and who don't get the treatment, right? Like, as you see, I cannot force you, hey, don't go to college, just stay as a high school graduate. Or don't study, just go to the lecture, but just don't study and see what grade you get at the end of the semester. It's something that I cannot do. And so what I can do is just, deal with observational data. Now, observational data is going to be quite challenging in terms of identifying a causal effect, okay? But then in this semester, we're going to try our best to really understand why it's very difficult to identify causal effect, and then, if possible, what are the tools that we can use? What are the econometrics tools that we can use to identify the causal effects? Okay. All right. Any questions about experimental and then observational data in general? Go ahead.
Excuse me, sir. I'm
Yes.
sorry. Just for confirmation, both of the experimental and the observational data is to proving a causal effect, sir, or it's correlation and causal, sir.
Yes.
Or it's a causal effect like that.
Yes. So ideally, what we want to identify is the causal effect. Okay. But again, identifying causal effects are going to be very challenging. So I'm not going to limit your learning this semester into only identifying causal effects. But you have to go and try to understand the difference between causality and correlation. And even if you try to identify or uncover correlation, you understand kind of like the drawbacks of just uncovering correlation. Okay, so just by uncovering correlation, we cannot make a strong claim that X causes Y, or we cannot make a strong claim that, you know, if you study more, you know, you're going to get a better grade. It has to be more than that, for example, you know, if you invest more your time on learning, then you will get a higher grade and stuff like that. So it's not the only causative fact that we're interested in this course, but also correlation. But at least if you identify or you uncover correlation, then you know kind of like the challenges in just knowing correlation, particularly for policy evidence. Okay, I hope that's clear. But any other confirmation?
I'm sorry, sir. So I mean, what I mean is that this is experimental and observational data. In the experimental and observational data, we basically trying to prove it is have a causal effect to the experiment, sir.
Yes.
Causal effect. Okay. Thank you, sir.
Yes, basically, yes. So the idea is that, so ideally, yes, for every experimental and observational data that we get, we aim to identify the causal effect. But again, practically, it's going to be challenging, especially for everyone in the first semester knowing econometrics, to really know the tools on identifying causal effects. So I'm not going to limit you guys just to only understand and estimate causal effect, but you know, you will explore identification of correlation and stuff like that. However, knowing the drawbacks or the limitations of correlation is going to be very useful for you not to make a strong claim about correlation being a causal effects, particularly when it comes to policy discussions. Okay, I guess that's going to be the note. Okay, so there are challenges in us getting a causal estimate. Okay, so one is about the inference. It's about quantifying uncertainty due to the limit data. The second is modeling. Okay, so you know, theories and empirical results will tell you that there are a lot of variables that are correlated with a specific variable of interest or outcome variable. And so we need to do some modeling to try to make complex data comprehensible. And third is about identification. So what is an identification? Well, an identification is kind of like an exercise or a procedure for us to get or identify causality from non-experimental data. Now, again, this is something that we're gonna revisit, we're gonna go through as we go along. And so I think it's gonna be a challenge, but also it's gonna be fun at the same time, okay? So I'm gonna start with inference first, and then we can go and then discuss the other points, okay? So I think I'll start with the inference. I'm gonna discuss a canonical example, which is polling for a presidential election, okay? So I mentioned this earlier in the lecture that we need to try to separate between anecdotal evidence and data, okay? So we cannot base our decisions, particularly policies, important policies that take up a lot of resources, such as budget and then human resources, and then use that for policy making, okay? So we really have to distinguish between anecdotal data and anecdotal evidence and data in general. Okay, so in relation to polling for a presidential election, can anyone give an example of anecdotal evidence versus data?
I'm sorry, sir.
Yes, go ahead.
Maybe I'm wrong, maybe. And the anecdotes data, I think if I'm remember, it is said that it has a specific time or something, I forgot. So basically like for limited time, I think. So basically like survey has a limited time before the official one. So I think like in the presidential election, there is some kind of survey polling. That is the anecdotes. I think so, like that.
Okay. All right, any other?
Sir,
Yes, go ahead.
I think this is within the presidential election, not about the presidential election itself. But I think when there are allegations of voter fraud, I think some of them are, all of them are anecdotes in this case.
Yeah, okay, good. Maybe just one more. Probably like a... Okay, so yes, go ahead. Matthew, you wanna have something to say?
Maybe if we go back to the cigarette example, the example of someone saying like, oh, my uncle smoked for 50 years and didn't get cancer, that would be anecdotal, but empirical evidence would be actually analyzing the correlation between cancer occurrence and per capita cigarette consumption in the country, I guess.
Okay, so for example, you just went to a poll station and then you chose your candidate, or you voted for your candidate, and then you talk to someone. Who did you pick? Who did you vote for this election? And then the other guy said that, oh, I voted for candidate A. Oh, I did too. I did vote for candidate A. Oh, he must be winning. And so just by talking to one guy who probably he knows, who maybe in the past shared discussions that they have the same presidential candidate, and then claim that by just that one data that the presidential A or the candidate A is going to win. That's an example of anecdotal evidence. Okay, and so we cannot just base our decisions, more importantly policy decisions, based on just anecdotal evidence. We have to rely on data. So what kind of data is actually valid for this? Well, you have a population of polling stations in Indonesia, and then what you want to do is try to take a random sample of these polling stations. Maybe you can do stratification by provinces, you can do stratification by previous like political affiliation of each polling station regions and stuff like that. And so by having a random sample, you can make a better inference on the presidential election. Okay, so that's kind of like the ideal. Of course, we cannot, or it's going to be very, very difficult. It's going to be very, very expensive to poll the entire population. Okay, so suppose that there are 80 million of people who voted, then it's going to be very, very difficult and very, very expensive to get the data from those 80 million people who voted. And so what do? Well, as you've learned in statistics, if you have a population, what you can do is randomly select individuals as sample. Okay, so the key here is random selection. You can do stratification, you can do cluster random sampling, and so on. But the idea is that you have to take a random sample, and then using the random sample, you can try to make some inference about the population preferences or the population characteristics. Okay, and so based on the randomly sampled voters, then the predicted winner is candidate, say, A or candidate B, stuff like that. Okay, now in some cases, we're going to be facing with just a finite sample. And so what can we do? Suppose that if we have uncertainty associated with a finite sample. Again, this is something that you've encountered in statistics 1 and statistics 2. Central limit theorems is going to help. Okay, so central limit theorem is, I think, one of the most important results in probability theory, and the theorem suggests that the Z transform of the sample mean is asymptotically standard normal. Okay, so no matter what the shape of the original distribution, suppose that we have a variable X. Okay, X may have a uniform distribution. X may have a beta distribution. Variable X may have a gamma distribution. but the mean or the sampling distribution of the mean is going to approach a normal probability distribution as you have more observations, okay? So that's the idea of the central limit, okay? X, variable X may come from, uniform distribution or any kinds of distribution. However, the average or the sample mean of X is going to follow a normal distribution, particularly after you get more sample, okay? So that's the idea of the central limit theorem, and it's going to help us a lot in econometrics, okay? So we're going to use this notion on and on again. Any questions on the central limit theorem? It's always good to revisit the central limit theorem. I think it's a very, very useful idea. And if you have time, you want to hone your skills on theta and R, you can do a simulation. And then using the simulation, you can try to kind of like make a graph of the central limit theorem. I think it's cool. It can easily be done. It just takes like probably a couple hours of your curiosity and time to do it. I invite you to do that. It's a very cool concept, okay? All right, any questions? Otherwise, we can go to the modeling section. Okay, all right. So we're gonna go to the modeling. I'm just gonna go over one slide and then let's take I think a 5-minute break, and then before we go back. So again, models are basically maps of reality. We're not going to be able to identify all variables that may affect a particular variable or particular outcomes, but we need that model to try to map that reality, okay? Now, as you know, reality is very complicated. Perfectly accurate map will be as large as the territory, okay? So suppose that you really want to know, the map of Yogyakarta, then it's just going to be very difficult if you, shrink the actual Yogyakarta map into a one-page map that you carry or something that you have in your handheld device. It's going to uncover a lot of like the true details, but then sometimes having something that is simple may be quite useful for us to really understand the reality. And so what we're going to do is we're just going to do a mapping just accurate enough so that we're able to answer the question of interest. Now we understand that this varies from context to context. So when we do an estimation on, say, return to education, it's going to be very different when we're doing, the effect of training on micro and small enterprises productivity, but understanding what's possible and what's not is going to help us to really understand modeling in general, okay? Now, I've been going through modeling very abstract, in an abstract way. And so after the 5-minute break, we'll try to give you more, kind of like a real example of what modeling is, okay? So let's go back at 14:55, and we're going to continue our discussion on modeling, okay? Let's take a break. Okay, so I'm gonna give you time to restart. Okay, all right. Before I go on and discuss about modeling, any questions on inference, on modeling, or any of the previous concepts? Go ahead. Okay, all good. All right. So we'll discuss more about modeling. So basically, we will want to start with an economic model. So I guess you've gone through the introduction of economics, and then you've gone through microeconomics. So the idea is that in economics, the basic premise of a model is a utility maximization. Okay, so if we're talking about firms, then we're talking about profit maximization or cost minimization, and so on and so forth. Okay, so now let's go back to the idea of individuals' utility maximization. Okay, so for example, individual choose consumption basket that optimize their utilities subject to budget constraints. Okay, and then we can then derive a demand equation, which is a function of, can anyone remember, if you have a utility as a function of good A and good B, and then you have a budget constraint with the prices of good A and the prices of good B and your income, what would be the demand equation? Or the demand equation is going to be a function of any, can you guys recall? Okay, so if you guys remember, then the demand equation is going to be a function of the prices of good A, good B, as well as your income. Okay, so the demand equation is going to be the basis of an econometric analysis for consumer demand in general. Okay, so start with the theory. So the theory is going to provide you with kind of like a guideline and a prediction. And then you're going to use econometric specification, you're going to use econometric model and try to make estimate of the prediction. Okay, all right. So the next one I think is a very interesting example. So this is economics model of crime. This model is due to Gary Becker. He's one of my favorite economists. So if we go back at that time, I think Gary Becker made a very significant contributions to the field of economics. Okay, so Gary Becker introduced economics as a tool to understand social phenomena such as crime, and then discrimination, and then human capital, and then family economics, and so on. So I think he was a very influential economist, given the development of economics during the time. Okay, all right. So we can try to have kind of like a theory on individuals' participation in criminal activities, and so individual, when you want to do like a particular crime, you want to identify the benefits and the cost. Okay. So, okay, the benefit of, say, cheating in the course will be to get a pass. And so by getting the pass, you don't have to retake the course next year. But then what are the costs? Well, the cost, if you get caught, then, you will get an E, you will get, formal warning letter from the vice dean, and then you have to retake the course anyway, okay? And so as an individual, you're going to try to weigh the benefits and the cost of, doing crime. Okay, I want to, grab someone's purse. And so I'll get whatever is inside the purse. But then if I get caught, I'll probably get, beaten up. I'll probably get thrown in the jail, and so on and so forth. Okay. And so basically, individuals have to try to think about the benefits and the costs. And so this is not limited to just crime activities. When you chose to go to school, you also think and weigh the benefits and the cost. Okay. Okay, so by going to school, I'm going to spend tuition fees. I'm going to spend monies for my stipend, for where I live, and then my lunch, my dinner, my breakfast, and stuff like that. And also, if you decide to go to college, there's also an implicit cost. What's the implicit cost of going to college? Anyone?
Opportunity cost of
Exactly.
learning.
Yes. So the implicit cost of going to college is going to be the opportunity cost of your time. So if you don't go to college, you might be working, you could be an entrepreneur and making money, or you could be working in an office. But then if you go to college, then you're spending some costs right now. But in 4 years, in 5 years time, you're going to get a degree, you're going to get a better job. Relative when you decided not to go to college, you get a higher, better benefits from the job, such as health insurance. You probably get benefits to go to training, which improve your human capital even further, and so on and so forth. So basically, in every situation, economic individuals try to think about the benefits and the costs of a particular decision. Okay. So in the economic model of crime, you basically try to identify what are the benefits of doing crime versus the cost of doing it, okay? And so what are the factors? It could include the wage in the criminal activity. So what do I mean by the wage in criminal activity? How much do I get if I actually do criminal activity, okay? Another factor is the hourly wage and legal employment. And why is that relevant in the decision-making of a crime activity? Any thoughts?
If I may.
Yeah, go ahead.
So I think the disparity in income between the legal and illegal job may cause illegal job to become more tempting for those who don't actually have the skills to enter the legal job.
Exactly, that's one explanation. Another explanation is that, if you have the skill, but then you chose to forgo it to do criminal activity, then the opportunity cost of legal employment is going to be very high. And so it could go either way. So it's very interesting. Another factor is the income other than from crime or employment. Okay, so this is kind of like the other alternatives that are available. And then the probability of getting caught, the probability of being convicted if caught, and the expected sentence if convicted. Okay, so these probabilities are benefits, or are these probabilities costs? What do you guys think? So these probabilities are actually the cost, right? So, probability of getting caught. So it could be the statistics. So, maybe 3 out of 10 murder cases are solved, or 6 out of 10 burglary cases are caught, and stuff like that. So these are the probability of getting caught. And if you get caught, what's the probability of being convicted? Or maybe it's 90%, or it's 80%. And by, what's the length of the expected sentence and stuff like that. And so, if you're interested in the economic model of crime and corruption in general, Pak Rimawan Pradiptyo has very interesting results from his research. And one of the interesting results is that it's not about the probability of getting caught is very low, but it's actually the fine or the expected length of sentence if you get convicted from corruption activities is still very low, okay? And so there is no deterrence effects from these punishments. And so rationally, it's beneficial to do corruption. And so that's why we see why there is still a high incidence of corruption in the country. So, that's one application of, benefits and costs in this particular model. All right, so in the previous slide, I actually wrote a particular function. So it's a function f. So this function must be correctly specified to construct an econometric model. So you can think of the simplest one is just a simple linear model, okay? Where we have a linear model in terms of the parameter, and we have linear model in terms of the variable. We'll talk about more. We'll talk more about this one. All right, so can we find the data for variables in the model? So in terms of crime, it could be like the crime rate in the particular economy. It could be the wage rate in the market. It could be the frequency of arrest. It could be the frequency of conviction. It could be the average sentence. It could be the age, okay? Now, when I'm writing the model, I usually write beta 0, beta 1, beta 2, beta 3, and so on, okay? So this beta 1, beta 2, beta 3 are what's called parameters, okay? Now, do we know the value of parameters? Again, going back to statistics, it's difficult to know the value of parameters because parameters is something that belongs in the population, and we don't know the value of the parameters, okay? Now, what's also interesting in a lot of econometric model is going to be the term U. It could be U, some people write it as an E, but the idea of U is going to show the unobserved factors, or it's going to depict the unobserved factors that affect crime at the same time, okay? So what are the factors that affect crime other than the ones that we already see in the model? Well, it could be the wage for criminal activity. Maybe in that particular region, it's actually very beneficial to do crime activity, okay? It could be moral character, you know, for individuals with, you know, a high moral ground, then it's, you know, it's just very difficult to do crime activities. It could be the family background. It runs the family to do crime activities, or the opposite. And probably other issues like measurement errors, okay? So as an economist, not only that we're interested in the variables that we observe, we're also very interested in the variables we do not observe, okay? So this is very preliminary, but the factors that we do not observe can be very much correlated with the variable of interest. In this particular case is the crime. But then at the same time, they could also be correlated with other variables of interest, okay? The wage and stuff like that. Now, knowing the unobserved factors or the unobserved characteristics is going to allow us to better identify the estimate of this parameter in the model, okay? So again, knowing better what the unobserved factors are going to help us to identify the estimate for this beta 1, beta 2, beta 3, and so on, okay? All right, any questions before I move on to the next slide? Okay, so basically, again, the next slide is again going to reiterate the importance of the unobserved variable. And so dealing with the error term U is going to be most important component of any econometric analysis, okay? So in the early days of, or in the early weeks of Econometrics 1, I'm going to push you to really understand what are the unobserved variables, and then what are the consequences of not having these unobserved variables in the econometric specification, and particularly in the estimates of your model, okay? So make sure that we'll be on page on that one. So with that in mind, I'm going to start with the first discussion. So this is a very important model in the labor economics discipline. It's referred to as the Mincerian model, which is you know, a model first derived by Jacob Mincer. So the model looks at you know, the effect of education and experience on labor market wage. Okay, so on the left-hand side is the labor market wage. On the right-hand side is the years of schooling, education, the years of experience. This is you know, the years of working, and then training. What are we interested in? So we're actually interested in beta 1, Data one is called, or usually called, the return to education. We're going to use this term over and over again during the lecture. So what is the return to education? So return to education is additional wage that we get from additional years of schooling. Okay, so that's the idea of the return to education. So on average, for individuals who attain 1 more years of schooling, then they will have a higher wage in the labor market, say by some particular rupiah. Okay, so that's the idea of return to education. Okay, but we're not interested in the return to education yet. We're interested in variables that are not observed in the model. Okay, so I'm going to give you guys 20 seconds to think about what are the potential variables, you know, that could affect the wage, and it's not in the model. Okay, so what are the factors that may affect the wage, but it's not in this particular model? All right, 20 seconds. If you have any ideas, suggestions, you can always unmute. Any?
Sir, may I?
Sure, go ahead.
I think the same with the crime function. The U can also has the family background variable.
Okay, very good. It could be the family background variable. It could be the father's education. It could be the mother's education. It could be, you know, family income or family earning. Family income and family earning could provide you with an illustration of the resources that the household have. And so individual with better resources may provide their children with, you know, a better education. They could provide their kids with better resource support for the education. Family background may also extend to the network, and the network may affect you know, the job of their children and stuff like that. So yes, family background is very, very important. Other than family background, any other ideas, concepts? There's tons of variables that are not observed in this model. So you know, I can like get 20 of you to think, and you guys can be still correct. Okay, go ahead. Any other ideas?
Sir.
Yes, go ahead.
Maybe talents or innate ability.
Yes, so innate ability is something that is very difficult to observe, and it's actually very important. Okay, so I'm gonna again briefly introduce you. So innate ability is one of the unobserved factors. Okay, so innate ability is correlated with the wage. Okay, so you know, if you're a more able individuals in terms of communication, in terms of you know, teamwork and stuff like that, then you know, you can have a higher wage independent of the education. But at the same time, innate ability is also going to affect your education. More able individual may attend higher education. So this is going to be the complexity that we're facing when we're doing econometrics model, is when we have factors that we do not observe, and at the same time, it correlates with both the outcome or the dependent variable and the variable that we're interested in. In this case, is the education. Okay, so I'm not going to go in depth and then explain the concept in this lecture, but it's going to be something that I go over and over again in future lectures. Okay, now, other than innate ability, family background, can you guys think about other unobserved characteristics?
Sir, can I?
Yeah, sure, go ahead.
It's their motivation to work and the people's character.
Yeah, could be. Yeah, exactly. So motivation, and then you know, more motivated people, you know, they work more and probably they get higher wages. But the issue with innate ability, the issue with motivation is that it's very difficult to observe in the data. So if you open up IFLS, if you open up, say, the National Socioeconomic Survey or the National Labor Force Survey, rarely that you see innate ability as one of the variables for you guys to use in the econometrics data. Okay, even so motivation. So it's very difficult. But studies have shown that motivation, grits, perseverance is going to be correlated with labor market outcomes such as wages. Okay, there are tons more ideas.
Connection, sir. I'm sorry.
Yeah, network connection. That's another thing. I'm surprised none of you guys mentioned gender. There is the idea of gender wage gap, which is the average difference in the wages of female and male workers in the economy. It's a very interesting topic, one that I invite you guys to learn. There could also be differences in wages by different economic sectors, such as the agriculture, the industry manufacturing, services, construction, finance, and stuff like that. Excuse me. There are also differences in terms of the occupation. So suppose they are sales, they're managers, production workers, civil servant, that also affect the wages. And so those are the variables that we also need to control for. And we can also think big in the sense that, there are, these workers are coming from different regions. Some are coming from Jakarta, some are coming from Surabaya, other provinces outside of Java and stuff like that. So there are differences in the labor market characteristics. And so we have to take into account those characteristics as well. Okay. And these characteristics are not shown here in the model, but they're here in the unobserved variable. Okay. Now, as you go along the lecture, you'll see, you learn more and more variables that are relevant in the model. They are available in the data. And so you'll be, keep getting more and more idea into the model. Okay. All right. Any questions before I move on to the next slide?
Sir, may I ask?
Yes, go ahead.
For the parameters, the beta, it shows like the strength for the relationship between the variables and the wage, right? So what does the beta zero, the relationship was?
Okay. Yeah. So beta zero is it's a parameter that shows the average wage if individuals have zero education, zero experience, and then zero training. Okay. Again, so this beta zero is not intuitive at this moment, and it's not something that is usually cared about. So people don't really look into the beta zero. But yes, in the next lecture, we'll try to really understand what beta zero is. Okay. But in general, we don't really, not that we don't care, but it's just we don't pay that much attention to beta zero. But very good question.
Okay, thank you, sir.
Okay, so we've talked about identification, we've talked about modeling, we've talked about inference, we've talked about modeling, and now we're going to talk about identification. Okay, so what is identification? Identification basically is a process or a procedure to determine causal effects with non-experimental data. Okay, so as you've seen in the previous slide, there is ubiquity of unobservable confounding variables that may influence outcomes, and the confounding variable is going to make identification of causal effect very, very, very challenging. Okay, so I'm going to go back to the previous slide, and then I just want to identify again one particular unobservable characteristic is innate ability. Innate ability is correlated with wage, but then at the same time, it's also correlated with education, okay? And so this kind of variable is called confounding variable. And confounding variable is going to make our life difficult or challenging in terms of identifying the true beta 1, okay? So if you have a model and then you think that there is a confounding variable, then estimation of beta 1 or perhaps beta 2 or beta 3, depends on what you're interested in, is going to be very challenging, okay? So in terms of statistics, your estimate could be biased, okay? So what does bias mean? Bias means that, the population parameter has the true value, which we don't know. And then the estimate that we get from the model is actually quite different with the true value in the parameter. Okay, so this is going to be one of the challenges that we're going to face when we're dealing with non-observational data. So we're going to be facing with a lot of unobservable confounding variables. Okay, now again, this is still the first lecture. I don't want to drag you deep into this issue of confounding variables, but when you go into the second chapter, when you go into the third chapter, then the issue of confounding variable is going to be quite resound. Okay, all right, so we've talked about educational attainment on labor market earnings. We could talk about the effects of high school quality on labor market earnings. We could talk about the effects of smaller classes on elementary school student achievement, or the effects of religiosity on annual donations. And if we go back to the early discussion, is it smoking that causes cancer, or is actually smoking and other behaviors such as their diets, such as their exposure to pollution and stuff like that, that affect the cancer? So trying to disentangle that, that's going to be the challenge in the research. Although studies have shown that smoking indeed leads to a higher incidence of getting cancer. Okay, all right, so I'm going to take one example here, which is the effects of smaller class sizes on elementary students' achievement. Okay, before we go there into the confounding variables, what's your prediction? Smaller classes, higher achievement, or larger classes, larger classes, higher achievement? Which one do you think is true? It could be theoretic, it could be empirical. What do you guys think? Studies have tried to show that smaller classes actually has a positive effect on student achievement, but then it's going to be very difficult to disentangle the effect of class sizes on student achievement. Can you think about confounding variables that may affect elementary school achievement and elementary student achievement and the class size as well? Can you think about any confounding variables? Factors that are outside of the class size and outside of the student achievement.
Hello, sir. May I try?
Sure, go ahead.
Does the complexity of the course matters, like how hard it is, and I don't know, the generosity of the lecturer, maybe?
It could be. It could be, again, going back to the family resources. Students from probably a more affluent households, they have resources to get their kid into smaller class sizes, and so at the same time they have more resources that they can dedicate to improve their student achievement. So it's going to be very difficult to disentangle. Are we seeing the effect of smaller class sizes, or is actually the effect of the smaller class sizes plus the family background? So econometrics will try to allow us to disentangle the effects between these variables, particularly the variables of interest and the confounding variables. Okay, so that's the idea of identification. Okay, now again, this may sound abstract, but this is going to be the issues that we're going to face moving forward in this econometrics course. Okay, questions? Okay, good. So one more. On the effects of high school quality on labor market earnings, what do you think are confounding variables for this particular question? So what are the factors that we do not observe, which affect the labor market earnings, and at the same time correlate with the high school quality. Any idea? Or another way of doing it is that when you want to try to isolate the effect of high school quality on labor market earnings, what do you think are the variables that could potentially confound that? So what is high school quality? So in the literature, high school quality refers to the teacher quality, usually represented by the share of teachers with a master's degree or a bachelor degree. It could be the expenditure per students in the school. So the higher the expenditure per school, the higher the quality of the school. It could also be the student and teacher ratio. So these are kind of like some of the school quality aspects that we usually use. But there are more, like the availability of library, the availability of tutoring, the availability of computer lab, for example. Can you think of confounding variables that could affect your estimate on the high school quality? Ideas?
If I may, sir.
Sure, go ahead.
How about locations that like in a certain location, certain region, the lack of high school quality may the lack of high quality schools may lower the standards of high school quality, and that will affect the labor market also, labor market earnings also. Yeah.
Exactly, very good. So it's going to be the regional, like the regional characteristics could have, an effect on the labor market earnings, but then at the same time, some of the regional characteristics correlates with the quality of the schools. So we can, I always think something in binary, because by thinking in a binary ways, you can try to reduce the problem. So you can think of rich region, Jakarta, Surabaya, for example, versus poor regions. Okay, so in very rich regions or better regions, labor market opportunity is high, and then the school quality is high. But then in poor regions, job opportunity is very scarce, and at the same time, the quality of schools are usually low as well. And so we cannot really separate, is this because of the school, or is it because of the local labor market situation that is affecting my labor market earnings? So that's a very good example. Okay, and again, family background is another confounding variable. Parents with coming from more affluent background may allow the children to go into high school quality, and at the same time they have more resources to push their kids onward. So it's very difficult to say whether this is really the school or is it the resources that the family have to support these children. Now, this kind of discussions, trying to understand what are the unobservable factors and then the confounding variables is going to be the key or one of the keys in Econometrics 1 course, okay? Now, the others are going to be quite straightforward in terms of how do we do regression in Stata, how do we do regression in R, how do we interpret the estimated parameters. It's going to be quite straightforward. But in terms of thinking about the design, in terms of thinking about the potential ways of these confounders may affect your estimate is something that, needs creativity. So, I'm gonna introduce you to a technical stuff, but at the same time, I also want you to think a bigger picture in terms of concept, in terms of design, because this is what's really gonna help you in terms of learning econometrics, okay? So again, the goal of this course is really to try to introduce you to the standard statistical methods like linear regression model. We're going to start with a simple linear regression model, and then we're going to progress into multiple linear regression model. I'm going to motivate you to learn how to program in Stata. But again, if you want to program in R, if you want to program in SPSS, that's also fine. And so by the end of this course, you should be ready to do, methods for successful econometric modeling. You will be learning about simultaneity. You will be learning about unobserved confounding variables. You'll be learning all the issues related to simultaneity and unobserved confounding variables, and how these issues will affect your estimate. Now, at the end of the course, I want you guys to be able to really understand that. And I want you guys to be able to understand ways of coping with this kind of issues, okay? And we're also going to discuss empirical methods using applied economics and econometrics literature, okay? So this is just a very interesting quote by Hal Varian. At the time of writing of this slide, he was the chief economist at Google. So the question is, your job sounds extremely interesting. What jobs would you recommend to a young person with an interest and maybe a bachelor's degree in economics? And he said that if you're looking for a career where your services will be high in demand, you should find something where you provide a scarce, complementary service to something that is ubiquitous and cheap. So what's getting ubiquitous and cheap? It's data, okay? And what's complementary to data? Analysis. So his recommendation is to take a lot of courses about how to manipulate and analyze data, creating and managing databases, learning how to do machine learning, econometrics, statistics, visualization, and so on. And how will you differ from people in the IT department? How will you differ from people in the department of computer, for example? And the biggest difference is that you know the econometric theories. You understand kind of like the theories behind business and management. And so knowing the theories and knowing the statistical and econometric tools is a perfect combination, okay? So in other places, they know how to deal with data, they know the econometric and statistical tools, but they don't have economy theories. And so that's going to be one of the comparative advantages that you have, among other graduates. So I'm going to push you to really perform at this course because I don't think that you'll get a better opportunity to hone in your theories and hone in your statistical and econometric data and trying to have a critical thinking in terms of data analysis. I don't think you'll get a better opportunity than this course and in the future courses after you take econometrics, okay? So I think this is a good opportunity for everyone to learn. And I myself, I keep learning on the new tools and try to introduce them to students, and I'll be introducing some of my research as well during the course, okay? All right, so what are the types of data that we're going to be using in this course? The first one is cross-sectional data. So we're going to focus a lot on the cross-sectional data, particularly in the first half of the semester. So until meeting 7 or 8, we're going to focus on cross-sectional data. An example would be the national survey, like the Susenas, the Sakernas. Susi is a survey of industry. And then I think in meeting 9-10, we're going to learn about time series data. We'll learn more about inflation rate, stock market data, and stuff like that. Very interesting. I'm also going to introduce you to 2 types of data, which is the pool cross-sections data, as well as the panel data. These are very interesting data. You can learn a lot of things by, learning time series data alone. In fact, you will have a particular course just on time series data. It's called the macroeconometrics, which you can take, I think, in 2 semester time, okay? An interesting course as well. Next semester, after you complete the Econometrics 1 course, you can also take the Microeconometrics course, where we will, focus a lot on cross-section, pool cross-section, panel data, and in particular, we're trying to estimate the impact of particular intervention, estimate deep structural parameter in the economic model, and so on. Okay, So just quick questions, just to make sure that you guys are, getting aware of the data. So the manager of Kantin FEB, which is now missing a lot of customers through the pandemic, wants to know how people like their food selections, and she lets customers fill out a survey about how they like their food selection in Kantin FEB. What type of data did the manager collect? Is this cross-section data? Is it a panel data, or is it a time series data? What do you guys think? Yes, yes, it should be a cross-sectional. So the idea is that she liked to know a food selection within a particular time period, say during the space of a month for the survey. She's trying to understand what the food selections are given a set of sample. Okay, so it's a cross-sectional data. Any question on this? Any doubts on whether this is cross-section or this is other form of data? Okay, now students who take fundamental econometrics are required to fill out a questionnaire about the basic information such as their major, GPA, gender, etc. And I have collected the questionnaires for 3 years. Is it a cross-section, a time series data, a pool cross-section, or is it a panel data? What do you guys think?
Pool cross-section.
Okay, so I'm hoping it's not a panel data. If it's a panel data, then it's the same set of students for 3 years. And so it means that you'll be taking Econometrics 1 this year, you're taking my Econometrics 1 next year, and you're taking my Econometrics class again in 2 years. So you're stuck with me for 3 years if it's a panel data. So I'm hoping that you all graduate from this course this semester, and so you can move on with your life, okay? And so with that in mind, so it's actually a pool cross-section, okay? So I'm praying none of you guys are in my panel data for this, okay? All right, the last one. Students who take statistics 1 are required to take statistics 2 and statistics 3. I don't know how you feel about taking statistics 3 after statistics 2, but just for the sake of the example, you have to take both courses. And every time you take the course, you fill out the same questionnaire, okay? So is it a full cross-section or is it a panel data?
Panel data, sir?
Yes, this one is a panel data, okay? Why is it a panel data? Basically, we're following the same set of individuals when they were in statistics 1, statistics 2, and statistics 3, okay? So we're observing the same set of individuals across time, which is across different courses, okay? All right, so there are some subtle differences between panel data and pool cross-section. So basically in panel data, you're following the same set of units across time. But in the pool cross-section, you have different sets of units across time, okay? So that's going to be the difference between pool cross-section and panel data. It's very subtle, but then you'll get a hang of it after reading the textbook probably a couple of times, okay? Now, this is the end of our meeting today. I'm going to remind you that 1, you have to complete your quiz, and the quiz is held on ELOC. So you only have a limited amount of time to complete the quiz, okay? So you have to finish it after you access the quiz. So that's 1. Second, you also have a problem set that you need to do and a problem set that you need to complete and upload into ELOC. Now, one note is that I only accept a single PDF file. So if you have multiple pages, if you have, if you have a Word document, if you have a Stata do file, merge them into one single do file and then upload it into the ELOC. So ELOC will not accept if you have multiple files, okay? And the only files that they accept is a PDF file, okay? So make sure that 1, you take note of the deadline for quizzes. Make sure that you take note on the deadline for the assignments. Make sure you don't miss out on the quizzes, and make sure that you don't miss out on the assignments. Excuse me. And make sure that you also attend the tutorials, which will be held by Helga. Helga will be coordinating with you guys on the dates for the tutorials. Okay. All right. Any questions, clarifications before we close the meeting today?
Excuse me, sir.
Yes, go ahead.
So you mentioned that the only file that is accepted at alloc is PDF. Does that mean that we don't need to submit our coding file?
Yeah, so you will need to submit your coding file. It's very easy for you to convert your 2 files into PDF. Okay, and then once you have like a couple of PDF, just merge them together and then submit it as 1 file.
Okay, understood. Thank you, sir.
Mm-hmm. Others? Okay, so I know that this course is going to be challenging. I know that this course is going to be tough, but with the tough and hard training, it's gonna give you a lot of education and integrity regarding data. So, data analysis has never been easy. And so really knowing, the theoretical basis, both on the economics and the business sides, as well as the statistics and econometrics, will really hone you into a better data analyst for the future. Okay, so I really invite you to really take this course seriously, to learn about this course seriously, and I think the gains and the returns that you'll get, in the future from having a very good critical data analysis and critical thinking on data is going to be really, really huge. And so I think this is a good opportunity for you to start out that career for you in the future. Okay, so thank you so much for attending today's lecture. I may upload the video on Google Drive, or I may upload it into YouTube just in case you want to have future access to the course today. See you guys next week. Bye-bye.
Excuse me, sir.
Yeah, go ahead.
I'm sorry, sir. I want to ask about the quiz. Can you does the quiz is about our just study right now, or there is like equation like that, sir? Thank you.
So it really depends on the chapters. So for this first meeting, there could be equations, but it's more or less on the concepts. But in future chapters, there will be probably equations. There could be interpretations of numbers, interpretations of regression results. It really depends on our discussion. And allocs actually allow us to write in LaTeX, and so we'll be able to show you equations.
Thank you.
Okay, so I think that will be all for today. It's really good to have everyone's here. Again, it's a long semester, so I'd like you, to maintain your health, both physically and mentally. Again, I encourage you guys to work in a group, but not to copy and paste each other, but really to push yourself and push your teammates into better, not only for Econometrics 1, but also for other courses as well. Okay, I'll see you, and then have a good evening. Bye-bye.
Thank you, Mas Gilang.
Thank you, sir.
Thank you, sir.
Thank you, sir.